everyone, welcome to my channel. In thermodynamics series, next we discuss drawbacks of first law of thermodynamics. First one is it does not tell about the spontaneity of the reaction. Spontaneity is basically whether the reaction takes place by actually or not take place in reality. For example, if we talk about the uphill movement of water, is it possible there is the movement of water from the river to the mountain? No, it will not possible. For this we have to apply some pump or motors. But downhill movement of water from the mountains to the river, this is natural process. So this is spontaneous reaction. This first law of thermodynamics will not explain this concept. Direction of flow of heat. The first law of thermodynamics tells about the heat released or heat absorbed, but it will not explain the direction of flow of heat, in which direction the heat is flowing. According to first law, 100% heat can be converted into work. 100% heat released or absorbed, that will be completely converted into work. But if we talk in reality, this will not be possible, that 100% energy is converted to work. Next, this law doesn't tell whether a gas diffused from low pressure to high pressure. It will also not explain that it will also not explain that whether a gas diffuse from its high pressure to low pressure. These drawbacks are overcome by the second law of thermodynamics. Before starting second law of thermodynamics, first we will do some numericals related to first law of thermodynamics, heat capacity and enthalpy. Let's begin. Now let's begin with the first numerical. Calculate the internal energy. Internal energy change means delta U we have to calculate. Before starting any numerical, your first thing is to write the given things. Internal energy change, if a system absorbs 15 kilojoule heat, system absorbs 15 kilojoule heat, means heat is given to the system. When the heat is given to the system, then it is always positive. So Q is equals to plus 15 kilojoule. Next, and does 5 kilojoule of work. Work is done by the system. Whenever work is done by the system, then it is negative. So W is equals to minus 5 kilojoule. Now it's easy to calculate delta U from the formula of first law of thermodynamics, that is delta U is equals to Q plus W. Now put the value of Q here, which is plus 15 plus here minus 5. On solving, you will get 10 kilojoule amount of change takes place. There is a chance of mistake if you will not focus on these signs. If we will not take it as a negative sign, then it will become 20. So it's necessary that you have to learn the sign convention before applying to any numerical. Now come to next question. Calculate W, Q and delta U. What we have to find out? W, Q and delta U. Okay. When 0.75 mole, N is equals to 0.75 of an ideal gas expand. There is the expansion. Which type of expansion? Isothermal. Means temperature constant. And this process is reversible. At 27 degrees Celsius, T is equals to 27. Then we have to convert it into Kelvin. Add 273 into it. Then it will become 300 Kelvin. From a volume of, so V1 is equals to 15 liter and V2 is equals to 25 liter. These are all the given things mentioned in the question. After understanding the question, let's proceed further. First, we have to calculate W. Now, there are many formulas to calculate the W. That is, W is equals to minus P delta V W is equals to minus 2.303 nRT log V2 by V1, which we have to apply. Expand, isothermal and reversible. Reversible isothermal expansion. Then W is minus 2.303 nRT log V2 by V1. Now you tell me, we have the value of N. R is a gas constant, so you can take its value 8.314 joule per Kelvin per mole. R is already given. T is temperature. Here it is. Then V2 already given. V1 is also given. Now put these all values in this equation. What you will get? Minus 2.303. N is 0.75. R is 8.314. T is 300. And then log V2 is 25 and V1 is equals to 15. You can also write it as 5 by 3. Now W is equals to minus 2.303 multiply 0.75 multiply 8.314 multiply 300. To solve such log, what we have to do? Log 5 minus log 3. Now from the log table you can check the value of log 5 and log 3 and put it here. On solving this complete expression you will get 955.5 joule. Work is done. Now our W is calculated. Now delta U is equals to 0. Do you know why it is 0? Because there is isothermal condition. We know that internal energy is the function of temperature. If temperature is constant, then delta U is equals to 0. Now again applying the first law of thermodynamics. Delta U is equals to Q plus W. Now we want to calculate Q. Delta U is 0. Here W is minus 955.5 joule. Now keep the Q in this side and bring it here. Then Q is equals to plus 955.5 joule. This is the Q and this is delta U. This is all. Related to this, you can try the more questions from the book. Now come to next question. The heat of combustion of benzene at constant volume. Heat of combustion, we can write it as delta U, or it will also be called QV, because it is heat basically at constant volume, which is minus 3263.9 kilojoule per mole. Now next is temperature. Temperature is 25 degrees Celsius, which is 25 plus 273, which is 298 Kelvin. Now calculate the heat of combustion at constant pressure, QP, or you can say delta H. We have to calculate. So for this we have to apply formula delta H is equals to delta U plus delta NGRT. Now check. R is 8.314 joule per Kelvin per mole. Now check. According to this formula, can we have all the values? Delta U? Yes. Delta Ng? No. R is already present, T is also present. So first we have to calculate this delta Ng, then we apply this formula. Now there is the combustion of benzene. Combustion is basically what? C6H6 is benzene. Basically it is a reaction with oxygen. When it combines with oxygen, it will form CO2 and water. Now our next task is to balance this reaction. There is 6 carbon, so put 6 here. Here is 6 hydrogen, so we can put 3. 3 to the 6 hydrogen. Now we want to balance the oxygen. To balance oxygen, 6 to the 12. 3. 12 plus 3, 15. There is 15 oxygen. So we can write it as 15 divided by 2. So 2 cancel and we have 15 oxygen. This is a balanced equation. Now delta Ng. What is basically delta Ng? It is a change in number of gaseous molecules of products and reactants. Now this is liquid, this is gas, this is again gas and this is liquid. So we have to consider only gaseous moles. Here CO2 6 in products and 15 divided by 2 in reactants. On solving, take the LCM. 12 minus 15, it will comes out to be 3 by 2. Now we have all the values that we want to fill in this formula. Now put all the values. Delta H is equals to minus 3263.9 plus, here delta Ng is minus 3 by 2 multiply 8.314 multiply 298. On solving this complete expression, you will get 3267.6 kilojoule per mole. That's all. You can also solve such numericals from your book. Now move to the next part, heat capacity. Now see the next numerical. This numerical is based on heat capacity. Now see, calculate the energy needed. Okay, we have to calculate energy. Heat is also a form of energy, so we have to calculate Q here. Got it? To raise the temperature of 10 gram of iron, mass is 10 gram. From 25 degrees Celsius, T1 is equals to 25 degrees Celsius and T2 is equals to 500 degrees Celsius. Having the specific heat capacity is 0.45 joule per degree Celsius per gram. As I told you earlier that whenever temperature is given in degrees Celsius, then you have to convert it into Kelvin. But in this case, you have to see the units of specific heat capacity. In this case, you have to see the units of this heat capacity. Here it is degree Celsius, so you can use temperature as it is. Now there is a formula. Q is equals to mc delta T. Now put all these values in this formula. Q is equals to m is 10, C is 0.45 and delta T is temperature change, which is T2 minus T1. Now Q is equals to 10 multiply 0.45, T2 is 500 and T1 is 25. Now on solving, 10 multiply 0.45, it will become 475. On solving, you will get this amount of energy is needed. That's all for today. Thank you and have a nice day.